Hello my friends, in this video I'm going to be talking about activity number 2 in the creative synthesis module where we have to discuss subtractive synthesizers. So I've added the list of activities that we have to do to the clips over here. So the first activity we have to do, we can read it down here in the info, is we have to describe the basic modules found in a subtractive synthesizer along with the graphic representation of the basic subtractive synthesis architecture. So we will describe the modules as we're going. We can describe them. We'll be able to see them in the spectrogram and we'll hear them. But just to start off with the initial description of what subtractive synthesis is. Subtractive synthesis is in the name. It's subtractive. So you start with a rich sound source and then you use modifiers to subtract from it to leave you with something that you want. So an example, an analogy might be sculpting, where you'd start with a rich block of marble and then you chip away at it until it gives you the form that you want. And so we could start with something quite noisy and we would get away with the frequencies we don't want and it'd leave us with the frequencies we do want. So that's what it is. So that's the name of it, subtractive synthesis. It's called source modifier because you start with a rich source and then you modify it. So that's the basic description of it. If we look at the architecture for the one that we're using, analog, this comes from the model, from the manual, you can see that it's a very typical architecture. It's got two oscillators that will be controlled by two LFOs and a noise source. And so these are the sound sources, or the source. These can be mixed together and then they can be fed into, this is unusual in that it has two filters. Most analog synthesizers only have one, but this has two filters and they can be used either in series or in parallel. So you could go through the top one and out, or you could go through the top one and then into the bottom one and out, or you could go into two at the same time and out. And then there's two amplifiers. So the basic setup is exactly like this. It's oscillator filter amplifier. If this was voltage, it would be called a VCO into a VCF into a VCA. But if it's digital, it's called a DCO into a DCF into a DCA. And that's the basic architecture that was developed primarily by Bob Moog. So if we go back now and we'll have a look at what we're doing. So I've shown you an illustration and I've described the basic concept of it and I've described the typical architecture. So I think I've done a little bit of P2. We will go in and look at the modules in more detail now. But I'll just pick, I'll look at the modules in more detail. So we will go in and we'll start looking at the various modules. So firstly, I'm going to describe the sonogram, this thing that we're seeing up here. So if you can see there, it's showing me the harmonics. So as I raise the pitch, we can see it going up, and as I go down, we can see it going down. If it gets brighter, the louder it is. So it'll get brighter with loudness. And the vertical is the amount of frequencies. So if I put loud frequencies and I start to roll them off with the filter, we can see that I'm subtracting those frequencies and we will be left with just a sine wave at the end. Okay. So what we're going to do, that was just a description of this. What we're going to do is we're going to look at the individual modules. Okay, so the first module is the oscillator, and this is your sound source. And we can see, we'll just zoom in and we look at some of its parameters. We can turn it on and turn it off. I'm going to turn off the bottom one. We can turn it on or we can turn it off. Sorry, my friends. We've got a volume control on it, so this is part of our mixer. We can send it to filter 1 or filter 2 or mix. We've got different shapes. Notably, we don't have a triangle wave in there. We have pitch controls such as your octave, semi-detune, and then down here we have some further parameters that once you select the central well becomes for this parameter. And we've got a pitch envelope here with an amount and a time. We've got a pitch modulation with an LFO to create some vibrato. We've got pulse width modulation, which is a special effect that you can do with pulses. And then we've got sub and sync amounts. You can have an either or. Okay. I don't think you can have both at the same time. I'm not sure. So let's have a listen. There's a triangle wave, sine wave, pulse width, and we can change the width of the pulse. And lastly, kind of digital noise. So that has none. Okay. The next is the oscillator, so we can change the pitch. Go up and down an octave. Nice to see it jumping there. We can change the semitone. Semitone is more useful if there's two of them, really, because we can add two together and create like a fifth. And then we can detune. A detune again is more useful when there's two of them because we can hear the detuning together. It'll create a phasing. Kind of a beating, and we can see that there reflected in the oscilloscope as well, or in the spectrogram. It's quite pretty. We can put on a pitch envelope. Just turn off this one. We can make it go down, make it go up, and we can change the time. And we just get it to 0 again. We can change we can add an LFO on. We'll talk about the LFOs in a little bit, in the pulse width modulation and the sub and the sync. Sub just lets you add an octave underneath. And the hard sync it does a special effect where it syncs one oscillator to the other. They do it in an unusual way in this synthesizer, but it does do hard sync. It creates a kind of guitar-like or gritty kind of this tone. So that's the oscillator. It's your sound source. You could think of it like the strings on your guitar, whether they're nylon or steel string or what, the gauge of them. And we have two oscillators, and we also have a noise source. So the noise source is just noise, and it can be white noise, or it's got a filter on it, and you can kind of get it more like brown noise, or, well, not really brown noise, but more like pink noise maybe, or something like that. And you can choose. You can have all of them on at the same time if you'd like. And create a wacky sound. Okay, so that's the oscillator. We've done the noise as well. This is pink noise. It's whereas the oscillator has a tune, noise does not. We can see they're totally different looking. If we look at another one now, the filter. The filter is over here. This is we've got the oscillator, the filter, and the amp on the top. That's a monosynth, and the filter is probably one of the more important parts because it allows you to change the harmonics. So you can see it's filtering away there. Now there's different types of filter, and if you click in, you can see a list. So I'll just zoom in so we can see that list. And it's low pass filter. Low pass will let the high frequencies, it'll stop the high frequencies and let the low frequencies pass. A band pass will let a band pass and stop everything else. Notch is kind of a band reject. It'll cut out a band. High pass will let the highs pass and it will stop the lows. And formant is a vowel filter. Most analog synthesizers really only have low pass 12 or 24. It's more common. And so you'll see that they're removing the high filters. So you can pick the filter type, and then you can pick the filter cutoff position and the resonance. And you might be able to hear there that the resonance is basically a amount that the filter is being reinforced by this point. So it reinforces or makes the cutoff frequency that little bit louder. Okay. And you've got different types there, more aggressive. The higher the number, the more aggressive it is. So that's the filter. This particular filter allows you to saturate the filter. You can give it a little bit of drive, give it a little bit of a distortion. You've got symmetric or asymmetric saturation, which is quite nice. So second or third order harmonics. So that's the filter. The filter will just allow you to filter out some of those harmonics that we're seeing right now, and there's different types of filters to filter different types of harmonics out. For example, a band pass filter, we may as well do it. We'll only let, we need a resonance, but it'll only let a certain band. It'll only let a certain band through, whereas the high pass will remove all the lower ones. And then you could add in the second oscillator, you see. Have a different tone. You could add them together. Okay, so that's the filter. It allows you to remove or filter out certain frequencies. And then the amplifier. The amplifier just lets you turn it up, turn it down, and change the pan. So it's on the left or the right. I know, I've done something foolish, I believe. Oh yeah. So the amplifier lets you pan it left and right and lets you change the level. So there's not much that does, just like a normal amplifier. Now we are going to look at the envelopes. The oscillator, the filter, and the amplifier can be controlled by envelopes. The oscillator is a very simple envelope. It's just got a single line. It's more like it's not really an envelope. But these have fully dedicated envelopes. And an envelope is basically just a line. It's this, we could think of it as this blue line, and the sound will follow this line. It'll be easier to show on the amplifier. If I make this go in and out, this one will control the volume. So what will happen now is that the volume will fade in over time, get to this point, and then start to fade out, and it will stay here for as long as I hold the key, and when I let go of the key, it will then go into its release phase down here. So let's have a listen. We can see it. Now I let go. Okay. And we can change the attack time. Make it a quick attack, longer decay, higher, lower release. You can hear it. Make it a really quick decay. So you can use this to control the volume instead of using your manually, and you've got another envelope there that we can use to control the filter. So what I'll do is I'll just make this one standard, and then we'll use this one to control the filter. So it should get brighter over a period of 13. And you can increase the amount with the envelope amount here. Make it a little bit more. And with the two of them, you can kind of have some nice little fun. So you can see that I'm creating different types of sounds. Okay, so I think that I've shown you the envelopes, that they can kind of automate parameters over time, and they're primarily used to control the oscillator's pitch, the filter's cutoff position, and the amplifier's level. But it doesn't have to be. You can be used to control any parameter that it's allowed to control. The last parameter we have is called an LFO, and an LFO stands for a low frequency oscillator, and it's the same as your other oscillator, except it'll only work at low frequencies, which typically means frequencies below 20 hertz. Low frequency means they're unaudible to humans, we can't hear them, and so typically that means below 20 hertz. And what's most important about them, once we turn them on, is the shape. And so again, it's like another modulation, it's like a line. So whatever I attach the LFO to, whatever parameter, it will follow this shape. So what I'll do is I'll make it a more obvious shape. I'll put it to a rectangle, so it'll be on, off, and then we can just find things to attach it to. So I'll find and I'll attach it to the pulse width, the pitch. And so what we'll hear, I just have to make this a long sound, I apologize. And what we'll hear that it's controlling the pitch. If I put it to an LFO, or if I put it to the filter is getting brighter with this shape at that speed. So 1 hertz is 1 time a second. So it's just the brightness going up and down, and we could put it to a sine wave and it'll be more undulating. We could put it to a triangle, it'll be a little bit. And you can put it on the filter, you can put it on the amplifier, you can put it on the pan, you can put it on the level mod. So it's a way to kind of animate your sound and to get it a little bit more interesting. And so you have the envelope and the LFO. So the last thing that we want to talk about is the inverter, attenuator, and the mixer. So an inverter lets you turn lines that are going up, make them go down. So let's say this parameter here, if I want to invert it, instead of adding volume, it could be used to take away volume. So you invert the signal, you minus it instead of add. The other thing that we want to talk about is the attenuator. An attenuator just means a volume control. You attenuate the signal. You can turn it up or turn it down. And then a mixer allows you to mix several signals together. So we can see that there is an attenuator here with the volume controls for the noise and the two oscillators. These could be considered as attenuators. Collectively, it's a mixer because it all feeds into the same filter. So an inversion, we could make, for example, we can make the LFOs go inverted. So instead of going up and down, it would go down and up. Okay, so there's some things. Let's go on to the P4 and let's see what that says. Provide illustrations of the main modulation. I think we talked about that. Provide illustrations explaining envelope, LFO, keyboard tracking. Okay, so we have talked about envelope and we have talked about LFOs, but we haven't talked about keyboard tracking. So keyboard tracking is your position on the piano keyboard. So by default, the synthesizer will track the oscillator's pitch, will track your position. So if I play higher, let me just make a more normal sound, my friends. So if I track it, if I play higher up in the pitch on the keyboard, the oscillator pitch is raised. So that's normal. But you could do things as well, like have the keyboard track the filter. So as I play higher up, it gets brighter. If I play down lower, it's not just quieter, it's also less frequency. See, there's more frequencies coming in as I play higher and higher and higher. But as I play lower, there's less because the filter's cutoff position it's tracking the keyboard's position. You could also do it with the amplifier. So you could say, for example, that the higher up I play, the louder it is. Which can be useful. So that's keyboard tracking, and you can have certain parameters in your synthesizer. They'll track the keyboard's position, which is very nice again if you want to try and create a more immersive performance style. You can really get into that. Let's look at it. What else do we have here? And a continuous controller. So let's look at a continuous controller. Continuous controller is something that you can, like a mod wheel on your keyboard controller. It's a way to externally control some of the synthesis parameters. So in Ableton, this is pretty easy. All I do is I press the MIDI keyboard, I select the parameter I want to control, and then I move the knob on my hardware controller that I want to use to control it, and then I have remote control. Uh-oh, something went amiss. So that's remote control, and you can do that with any parameter that you want. So I'll also control the resonance, and maybe I'll control a bit of the detune on one, and maybe the detune on another. And then we should have a nice little performance synth, so we'll just turn them on. Turn this one up here. Clearly after doing something wrong there, but I'm not sure what, so we'll replace it. Cool. Okay. So that's that parameter, which was the continuous controller. So we've talked about illustrations of the envelope, the LFO, the keyboard tracking, and all that kind of stuff. To define modulation sources, detailing types of envelope. Well, we did look at different types. We looked at them controlling the oscillator, filter, and amp. And there's different types. You can have ones that have ADSR. This is an ADSR filter. It has an attack phase, decay phase, sustain phase, and release phase. This one is unusual in that it has a sustain time and it can be looped. So this is a very fully featured envelope with linear and exponential decay lengths and a legato mode. This is a very fully featured filter, and there's two of them. They're kind of the same. But you can get smaller envelopes, like with just an AD envelope, or you could get larger envelopes, which will have multi-stage envelopes, AD, break, D, or you can have envelopes with holes. This one, for example, has a sustain time. Or you can get multi-stage envelopes where it's just like a curve, you just draw a line. It doesn't have anything in particular. Okay. Define modulation sources listed above. Well, we did. We talked about them. Define how modulation sources relate to tremolo. So the LFO, if you attach it to a volume, will create. If you attach the LFO to the amplifier, it'll create tremolo volume changes. If you attach it to the oscillator, it'll create vibrato. And if you attach it to the filter, it'll create a kind of a wah-wah effect. And if you attach it to the pan position, it'll create an auto pan. So that's basically what they are. Playing with sustain. Tremolo, vibrato, percussive playing with sustain. Well, I don't know what that means. Evaluate common modules found. We've done that. Detail the controls. I think I've done that. Evaluate how these modules can be used to reproduce a wide range of articulations. Well, we'll do that in the patches, I think. But we can hear already that you can get it to sound pretty cool without a huge amount of effort. Put a little bit of reverb on it. And then if we just do a little bit of fading in, maybe do the fade in with the amplifier for maybe 5 seconds, a long decay out, a long release, let's say, okay? And with the filter we'll do. We do a long release on this filter. Up the resonance, let's try it now. Very Doctor Who, my friends. Okay, I think that's it for this video. I think I've done quite well explaining the modules, outlining them all, illustrating them, describing them, giving examples, explaining the envelopes. I'm sure there might be a couple of bits I've left out, but I've done a good job of explaining myself and showing that I do in fact understand this material. Okay, my friends, this would be acceptable to me as a product. Bye now.